Welcome students, this is a complete course on trigonometry. It starts all the way from basics and heads up to finish with advanced concepts. So with this course you will be able to tackle any trigonometric course offered by any universities all across the world. And it is imperative to understand that trigonometry is the universal language when it comes to any form of manufacturing engineering. So having mentioned that, it is important that you know this subject and have a complete grasp of this subject, because without this subject, as I mentioned to you, there cannot be any innovation, any creation when it comes to structural engineering. In fact, if you want to manufacture anything for that matter, you need the knowledge of trigonometry. Now, having mentioned that, let me just go ahead and introduce this subject. What exactly this subject is, you will have to understand the word trigonometry is a composition of two words. One is trigonon and the other is metron. Now this means triangle, this means measure. So if I were to write it in a single line, this means the science of measuring triangles. Right? Now you have to understand that in those days they did not have any devices at all. The only relevant device they had to create architectural marvels is the understanding of the triangle. More specifically, it is the right triangle. So that has to be taken into account. So if you have the knowledge of the right triangle, the very word says right, you can get all things correct. That is the basic way to illustrate or put the subject in a nutshell. So having mentioned that, let me just head on to define the following concept. Since I have just mentioned to you that it is nothing but the science of measuring, we are talking about the most important concept when it comes to trigonometry is the angles. So you will have to know what is an angle. So what is an angle? We are hearing so much about these, right? What are angles? So this is plurality. If you want to talk about in singular nature, what is an angle? Right? Now, an angle is nothing but, say for example, I'm mentioning it as theta, right? You can say theta, alpha, beta, anything for that matter. So, in most commonly, we use this Greek symbol theta. So, what is it? It is nothing but the measure of distance between two rays. Now, this is a key word. Now, what is a ray? What is a ray? Now, a ray is a part of a line, part of a straight line, part of a straight line that has a fixed starting point, but no end point. Right? There is a popular proverb which starts with this sentence or this phrase, a world without end. Right? Well, the ray is like that. So if you were to mention or represent the ray, this is the ray. So it has the starting point and no end point. So this is the start point. So it's a fixed point here. This is a fixed point. Now we are much bothered about measuring the distance between two rays. Say you got a ray like this and you got another ray like this, right? This is say OA and this is OB. Now theta would be present here. So this theta is the measure of the distance between two rays. So that is the understanding that you need to have. So just to have a recap, I just mentioned to you trigonometry being the most important sciences when it comes to any forms of engineering. That's point number one. Point number two is, what is the word trigonometry stands for? It is made up of two words. One is trigonon and other is metron. Trigonon means triangles, metron means measurement. So to put it in a phrase or in a sentence of understanding, it means the science of measuring triangles. As I mentioned to you, in good old days, the most important attribute of a triangle is understanding the right triangle. So everything was connected, correlated or related to the right triangle. In trigonometry, you will see a lot of right triangles. That doesn't mean that you're not going to see any other triangles, but you will see right triangles more too often. So, having mentioned to you the concept of right triangle, or bringing in the term right triangle, it is imperative that we start out with the basics. The first thing that you will have to know is what is an angle. As I mentioned, the angle is nothing but the distance between two rays, and then it comes to what is a ray. A ray is a part of a straight line which has a fixed point but no end point. So this is the basic example of a ray, and you got the theta. Now theta is measured in two ways. So how do we measure theta? So let me state this. Measure of theta is done in two ways. So one is anti-clockwise direction, and other is clockwise. Now anti-clockwise is always positive, that is this side, right? Now clockwise is always taken to be as negative. So have these understanding in the corner of your mind. So having mentioned this, let's go ahead. Now let me draw to you all the measure and sense of angle. Now this is the axis, this is x-axis and this is y-axis. Now imagine you have a ray starting from this point and moving up to this point. So this is one ray, right? And you got another ray over here. So this is say OA and this is OB. Now this line which you call it, or which you see, is called as the initial side. Have that in mind. And this one is called as the terminal side. Terminal side. So this is the starting point, this is the end point. So this is going to be theta. So we are interested in measuring this theta. Now in this case theta will be positive, and concurrently if I were to draw the axis, the coordinate axis x and y, and I have the ray OA here, and then I got the OB over here. Now if I were to, as I mentioned to you, this is the initial side and this is the terminal side. Now if I were to start the measurement from here and move down as it is the other way, then this theta value will be negative. So in this case it is anti-clockwise. This is anti-clockwise and this is coming down. In this case it is clockwise. So clockwise measure of theta will produce us a negative value, and anti-clockwise will produce us a positive value. So this is a very important concept. That's the reason I made it a point to mention this. So we'll move on. Now this is a very important concept. It is the relationship between degree and radian. You have to understand degrees is what is called as the hexadecimal system, and radians is what is called as a circular system. And using this system you can easily find another important term which is called as arc length and area of the sector. So these two important terms or technicalities can be achieved when it comes to any angle, or if you want to know the area enclosed by these angles. So having mentioned that, imagine that you have a circle in this fashion, and you got the radius. So this is the radius, and you got another radius joining them. This point is O. Now this is what is called as the arc, and in most of the questions you will be asked to find the length of the arc, right? And you got your theta, right? Now we always, to get the length of the arc, the formula is L is equal to R times theta. Now theta is measured in radians, so you will have to take the radian measure, even though they would be giving you in degrees. Relationship between, let me write that down. What is the relationship between degree measure and radian measure? So the faster we understand this, the easier would be the journey. So let me write that down. Degree measure divided by 90 is equal to 2 times radian measure divided by pi. So if I were to convert, say, 90 degrees into radians, then I will have to place 90 over there, divide by 90. This is 2 times radian measure divided by pi. So 90 gets cancelled. I move pi to the other side, bring 2 down. So this is going to be my radian measure, right? On the other hand, if you were to be required to convert 180 degrees, we always also indicate a degree like this. We place a small circle there. This is not 0, it's a small circle. So 180 degrees into radians. So what you will have to do is take 180, place it here, and divide by 90. Over here it's going to be 2 times radian measure divided by pi. So 90 divides here 2 times. So this is 2 times pi is equal to 2 times radian measure. 2 gets cancelled. Therefore radian is equal to what? Radian measure is equal to pi. So if you were to write the relevant degrees and radians, then this would be the following. So we started at 90 degree, but over here let me start with 0 degree. 0 degree is same as 0 radians. And then 30 degrees. You've got 30 degrees, it's going to be pi over 6. Then you've got 45 degree, it is represented as pi over 4. And then you've got 60 degrees, it's represented as pi over 3. 90 degrees, it's represented as pi over 2. Then you got 180 degrees, it's represented as pi. And then you got, if you want to move up, you got 270 degrees. Now you want to find the equivalent of 270 degrees. So you can use the formula. 270 divided by 90 is equal to 2 times r over pi. This divides here 3 times, so this is going to be 3 pi over 2. This is my radian measure. So 270 degrees is nothing but 3 pi over 2. Right? And then you've got 360 degrees. So you will want to know what is 360. So take 360, you divide by 90. This is going to be 2 times r over pi. And this divides here 4 times. So it's going to be 4 pi divided by 2. 2 divides here 2 times. So this means 2 pi. So radian measure is 2 pi. So this is some of the standard values of degree measures and radian measures that we would be encountering. So let me just move on. Now in this class I'm going to give you the simplified conversion factor. We started off with this particular formula, the way in which the degree measure is related to radian measure is given in the following fashion. So it's going to be 2 times radian measure divided by pi. Right? So this is what we had started off with. Now, whenever you're given degrees, if you wish to convert it into radians, all you need to do is multiply this quantity by pi over 180. So this is the conversion factor you will have to adhere to. Now you might be asking me, how did we get this? It's simple. What you need to do is move this pi up. So this is going to be degree measure times pi divided by 90. You bring this 2 down, so it's going to be 2 here. This is my radian measure. So what happens when you multiply 2 with 90? So you're going to get degree measure divided by 2 times 90 is 180. So just place that 180 there, and you got a pi there, and that is what I have written down there. So degree measure multiplied with pi over 180 will give us the radian equivalent. So have that in mind. So instead of going about these confusing stages, all you need to remember is, given the degree, multiply it with pi over 180. So this is the important conversion factor that you will have to know. Now conversely, you might be asking, what would you do if you are being given radian measure? How am I to convert it into degrees? Yes, you guessed it correct. So the factor would get reversed. So you have radians here, and if you want to convert it to degrees, to degree measure, all you have to do is multiply it with 180 divided by pi. This goes for both positive values and negative values, so have that in mind. So let me just give you some illustrations to reinforce. Say for example, you have got 15 degrees and you would want to convert it into radian measure. Now all you have to do is take 15 degree multiplied with pi divided by 180. That's it. Now you can make the reduction. Say 5 divides here 3 times, 5 divides here 3 times, and 3 times 6, and 3 divides here 12 times. So this is going to be pi over 12 radians, right? So that's the solution. Now say for example 330 degrees, say you want to convert 330 degrees to radians. So how would you do that? So let me use a space here. So 330 multiplied with pi over 180, I can cancel the zeros. I can reduce by 3. 3 divides here 11 times, 3 divides here 6 times. So this is going to be 11 pi over 6 radians, right? So that is the conversion that I've applied. So negative values also follow the same thing. The only thing is that you got to place a negative sign. So one more question. Say imagine you are given 210 degrees and you want to convert it into radian measure. You multiply this by pi over 180. Cancel the zeros. 3 divides here 7 times, 3 divides here 6 times. So 7 pi over 6 radians. So that is for the radian measure. Now imagine you are given angles in radians. Say for example you are asked to convert radians to degrees. So how do you do that? Say you are given pi over 6. So all you need to do is multiply it with the conversion factor. In this case it's going to be 180 divided by pi. Pi gets cancelled. 6 divides here 30 times. So this is equal to 30 degrees. right? And say for example you are given 3 pi. Next question, convert 3 pi over 2 to degrees. So what you got to do, multiply this by 180 divided by pi. Pi gets cancelled, 2 divides here, 90 times 90 into 3, 270 degrees. So I hope you got this point. It's very important. Okay, now there is another important concept you will have to know. This is important. The relationship between turns and radians and degrees. Sometimes they will ask you, say, now you have to understand that this is the circle. We always deal with the circle of measure in trigonometry. So if there is a question, say there is, say 1/24th turn, and you are asked to find 1/24th, 1 divided by 24, the turn on this circular measure. So how much would that be in radians and how much would that be in degrees? Now this entire circle is 2 pi radians. I have that in mind. The entire measure of this circle is 2 pi radians. So when they say 1 over 24, this means that 1 over 24 of 2 pi. So 2 divides here 12 times. So this is nothing but pi over 12. So when it comes to radians, they want you to find out what is pi over 12 in degrees. So you have to get the degrees. So as I mentioned to you, you want to convert this radians into degrees. You multiply by 180 over pi. So pi gets cancelled, and you got 4, right? 4 can divide 18 4 times, 16, 20, 45. 4 can divide this 3 times, so 3 can divide 45 15 times. So let me write that down here. Solution: 1 over 24th turn is nothing but pi over 12. In short, we write it as rad, which is nothing but 15 degrees. So this is a very important understanding. Suppose you are taking some scholarships examinations, MCQ will be used to filter people out. So questions like this would feature, right? Because these are all basics. So many times in MCQ, they want to check for the basics. If your basics are clear and straight, then nobody can stop you. So you have to get the first button correct, right? So understand the basics. So the next thing is, say for example, 1 over 16th turn. What does this mean? They want you to get the radian measure for 1 over 16. So as I mentioned to you, this is nothing but 1 over 16 of 2 pi. So 2 divides here 8 times. So this is going to be pi over 8 rad. Now what is pi over 8 rad? So you got pi over 8. Now you want to get the value. So it's going to be 180 divided by pi. So pi gets cancelled. Now 2 divides here 4 times, even 4 divides, I could have taken 4, but anyway I started with 2. So there's going to be 90, and 4 divides here how many times? 4 divides here 2, 4 2s are 8. No, 4 cannot do that. So I have to reduce it with 2. So 2 divides here 2 times, 2 divides here 45 times. So it's going to be 22.5 degrees. Okay, so this is going to be 22.5 degrees. 1 over 16th turn means pi over 8 rad, and in degrees it is 22.5. So probably I can give a few questions for you all to try them out. So I want you to find out what is 1 over 10th turn. You put the answer in the comment section. 1 over 12th turn and 1 over 6th turn, 1 over 4th turn. You have to do all this. 1 over 2 turn, 2 over 5 turns. Right? Find the radians and the equivalent degrees for all of these. Now, the next important topic that we would have to focus on is how exactly we're going to deal with decimal degrees. In other words, degrees which have got a decimal part. So that is also something that we need to focus on. Now, we have just seen how exactly we can convert degrees to radians and radians to degrees. And then we moved on to understand the relationship between turns and radians and degrees. And now it's time for us to handle degrees which do involve fractional quantities. So, having mentioned this, it is imperative to understand that 1 degree is equal to 60 minutes. So this is the representation, and let me write it in sentence form. 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds. And when we make the representation, we represent it like this: 60 prime and 60 double prime. So this indicates 60 seconds, this indicates 60 minutes. Now the next question is, how are we going to implement this? Now let me just give you a question. Say for example, convert 22.72 degrees into degrees, minutes and seconds. That's a question. Into minutes and seconds. So foremost, what we have to do is, we got nothing to do with the integral part, right? So all our focus is basically on 0.72. So what I wish to do is, I would like to take 0.72 and then multiply it with 60, because 1 degree is equal to 60 minutes. So we just multiply it first with 60. So when we do that, we would now have 6 times 2 is 12, 6 times 7 is 42, 43, and we got a 0 after the second. So this is how it looks, right? So when we write this, the decimal point is over here. So we have just successfully converted the fractional quantity into 43.2 minutes. Now you extract this fractional part. So this is 0.2. Now drop this. When I say drop this, it means we are not going to be looking into this for now. It doesn't mean that we can simply drop it off from the final solution. As of now, we are not going to be setting our focus onto the number 43. So we got this 2 minutes. So take this 0.2 and then you multiply it with 60. The outcome that you're going to get would be in seconds. So this is equal to 6 times 2 is 12. You got a 0, you place it there. Now the quantity here is, after the decimal place you got 1 digit. So you place a 1 digit. So naturally you're going to get 12 double prime. So when you're writing this, the most important part comes here is, how are you going to write this? So when you are writing this, this is going to be equal to, let me show that to you. 12, we started off, place that 12 degrees like this. And then this is in minutes, place 43 with 1 prime. And then this is in seconds. So it's going to be 12 double prime. So this is going to be the final answer. This is a very important topic, and specifically, as I mentioned to you in MCQ, this plays a very vital part. Students, we are expected to convert this quantity, negative 40 degrees 20 minutes, to radians. So foremost, we would have to convert this entire quantity completely into degree measure, right? So for that, you take this 20 minutes and then you divide it by 60. I already mentioned to you, 1 degree is equal to 60 minutes. So that is the reason I'm dividing by 60, because I would want to convert this quantity into degree measure. So clearly 0, 0 gets cancelled. You get 2 over 6, which is nothing but 1 over 3. So the understanding is 40 degrees 20 minutes is nothing but, of course there's a negative sign there, 40 1/3 degrees. This can be further rewritten as 40 times 3, that's 120, you add 1, that's going to be 121 divided by 3 with a negative sign degrees. So this is the entire conversion in degree measure. Now the question doesn't require us to give the answer in degrees. The question wants us to give the answer in radians. So you want to convert degrees to radians. What are you going to do? You take the value, which is negative 121 divided by 3, and you have to multiply it by pi over 180. So if you were to do this, this is going to be negative 121 pi divided by 3 multiplied by 8. 8 times 3 is 24, 2, 3 ones are 3, 4, 5, and that's going to be 540. So what is this? This is the radian measure for what? For negative 40 degrees 20 minutes, right? So that is the solution for this particular question. Now there is this concept, what is called as grad measure or grade measure. Sometimes you might be encountering questions involving, now if you want to convert grade to degree measure, then all you need to do is multiply the quantity by 90 over 100. So that is the conversion factor you will have to use. So based on that, let's do a question. So before I could start off with this measure, let me give you the spelling for this measure. The full form of this measure is as follows: gradients. So you can either represent it as GRAD or you can simply state it as gradients. Now the point comes here is, since I've just shown you, or I should say since I've just mentioned the conversion factor here, 90 divided by 100 to convert grade or grad into degrees, there is this equivalent relationship you will have to know, which is 100 gradients is equal to 90 degrees. So what is the meaning of this? It means there are 100 gradients present in 90 degrees. So that's the understanding of this statement. So as I had indicated to you, we will do a question which involves this grade measure and degrees. So the question is as follows: the angles of a triangle are given to be as 3x degrees, 4x over 3g, g stands for gradients, right, and 2 pi x divided by 75 radians, rad. So you got rad, grad and dig, right? So you're expected to find, if this is what has been given, find all the measures in degrees. Find all the measures in degrees, right? So let's get it started. So there's nothing here to convert because it already says 3x degrees, but we have to do the conversion for this. So 4x over 3g is converted into degrees by multiplying the quantity with 90 over 100. So this is going to give me the value in degrees. So this is nothing but 0 and a 0 can be cancelled. 9 times 4 is 36x, 3 times 10 is 30. So this is 30 degrees. Now it's time for us to convert 2 pi x over 75 radians to degree measure. Now this is equal to 2 times pi times x over 75. You want to convert this into degrees, you multiply this with 180 over pi. Now clearly pi can be cancelled, so you got 2 times x and then you got 180 divided by 75. Now you can use 15 times. 15 divides 75 5 times, and 15 divides 180 once, and then you got 3, and that's going to be 12 there. So 2 multiplied with 12 would give you 24, and you got a x there over 5. So we have achieved all of the conversions. Now a very important point. We know that the sum of the angles in a triangle equals 180 degrees. So that means the first angle is 3x degrees, and we have also converted the gradients to degree measure, and that was giving us 36x over 30 added with 24x over 5. This is equal to 180. Now if I were to take the LCM as 30, this one would give me 90x, this is going to be 36x, and this is going to be 6 4s or 24, 2, 12, 13, 14. So you got quite a number, so it's going to be 180. Now in fact you don't have to do this if you can reduce 36 over 30. As 6 divides 36 6 times, 6 divides 30 5 times. So in that way we would have a lesser problem in handling with huge numbers. It is not that you cannot do this, but sometimes some errors might creep up with whenever numeral calculations are involved. So we can avoid that by reducing these quantities prior to the simplification. So if I were to take 5 as the LCM, this would give me 15, this would give me 6, this would give me 24. Of course there is a x there, this is equal to 180. So this is going to be 30, 45 times x divided by 5 is equal to 180. This is what I've got. Now 5 divides here 9 times, so 9x is equal to 180. So x is equal to 9 divides 18 2 times, as 0 there. So x is equal to 20. Now if you remember, we were given 3x degrees, that's the first measure, and then for the second measure we got it as 6, we reduced it to 6 over 5 times x, and the third measure we reduced it as 24 over 5 times x. So substitute the value of 20. So this is 3 times 20, this is 6 over 5 times 20, this is 24 over 5 of 20. So this gives us 60 degrees, this gives us 24 degrees, this gives us 16, 1, 4 2s are 8, this gives us 96 degrees. So if you were to be given this question in choice, your answer should be 60, 24, 96. So that should be the solution for your question. Let's do this question, students. 2 arcs of the same length in 2 circles subtends angles 60 degrees and 75 degrees at the center, at their centers. You are expected to find the ratio of their radii. When it is plural, you say radii. If it is singular, you say radius. So Just to give a visualization, you got an arc in two circles. Say this is C1 and C2, and this is subtending an angle of say 60 degrees. This is 60 degrees, and let it be L1. This is L2, 75 degrees. Now if this radii is R1 and R2, we are expected to find what is R1 over R2. In other words, you can also write it like this: R1 is to R2. This is what is required, right? Now we already knew a formula that length, or I should say arc length, is equal to L is equal to R times theta, right? So in this case, L1 is equal to R1 theta, and it says same lengths. So in this case, even though I write L2 is equal to R2 times theta, this is theta 1, theta 2, this is given that L1 is equal to L2. So for C1, we've got L1 is equal to R1 times 60 degrees. Now 60 degree in radian measure is pi over 3, and L2 is R2 over, now you got 75 degrees. 75 degrees in radian measure. Now we can convert 75 degrees to radians by multiplying it with pi over 180. Now 15 divides here 5 times, and 15 divides 180 12 times, right? So this is going to be 5 pi over 12. So if I were to represent this, I got here 5 pi over 12. Now it's given that L1 is equal to L2, right? So what I wish to do now is, this is given. So because of this, I can equate these two components. So this would mean R1 times pi over 3 is equal to R2 times 5 pi over 12. Pi can be cancelled, and if I were to move these two things, cross multiply, it's going to be 12 times R1 is equal to 15 times R2. So 3 divides here 4 times, and 3 divides here 5 times. So we need R1 over R2, right? So therefore R1 over R2, move this R2 down. So you got a 5 there, and then you got a 4 there. Okay, so the ratio is going to be 5:4. Students, we have this question. The question is as follows: if the angular diameter of the moon be 30 minutes, how far from the eye should a coin of diameter 2.2 centimeter be held to hide the moon completely? Now let me explain to you this question. Now you have the moon and you got the eye watching the moon. Say let me draw the angular diameter. Now this is the angular diameter for the moon, and this is given to be as 30 minutes. So you have the eye watching the moon. Now you have to place a coin so that this coin completely blocks, right? Completely blocks the moon. We would have done this when we were little kids. Children always used to try to play this game. So the question wants us, how far should you hold the coin so that the moon is blocked? Now you've been given theta. Now theta is 30 minutes. That is the angular diameter. Now this is the coin. The coin is actually over here. So you are actually interested in finding out this distance. This distance has to be calculated. Now how are we going to calculate this distance? Now all that we can see here is there is an arc here and there is a theta. Now is it okay that we can use L is equal to R times theta? Can we use that to evaluate the distance? So that is an interesting question. So we are actually looking to find this length, right? Now the eye has been placed here. Actually, if we can stretch this, the eye would be the central point. So let me just stretch this like that. Okay, so the eye is actually the center and this is actually moving out like that. So that's the reason we were given the angular diameter. So since I placed this point over here, the eye over here, we are actually looking to get the distance from this point to the coin, right? The arc that is made by the coin. Now clearly, if we were to go and look into the arc length definition, the arc length is something of the same fashion. So this was termed to be as L, this is theta, and this is R, right? So this is what we are looking for, this distance. So that is nothing but the R that we are hunting for, and it is actually hidden. So we would be using this formula, L is equal to R times theta. Now we are given theta in minutes, so I want to convert into degrees. So what I wish to do is, foremost, I will have to, let me write that down. Theta is equal to 30 minutes is converted into degrees. To convert it into degrees, I have to divide by 60. So this is now in degrees. Now I already mentioned to you, whenever you are placing the value of theta, you have to place it in radians. So we have to convert this into radian measure. So to convert a quantity which is in degrees into radian measure, all that you need to do is multiply the quantity by pi over 180. So clearly I can reduce this quantity 30 over 60 into 1 over 2 and rewrite this as pi over 360 radians. So this is the radian measure. So we are actually got the following. We have the angular diameter, which is given, right? And R is what is required. So let me just place that, and theta is pi divided by 360. Now extracting the value of R, we would get 360 multiplied with 2.2 divided by pi, right? So this is the system we will get. Now we would take the value of pi to be as 3.14 and rewrite this as 360 times 2.2 divided by 3.14. If you were to compute this, this would be approximately 252 centimeters. So the value is 252 cm, and that would be the solution to this question. Now important observation is that you have to use the value of pi to be as 3.14. So have that in mind. Now it's time for us to learn about trigonometric ratios. Foremost, we need to know the three important ratios, which are known to be as sine theta, cos theta, tan theta. Now, when I say trigonometric ratios, they are nothing but the ratios for the right triangle. So if you were to take a right triangle, say A, B, C, this side is called as the opposite side. This is the adjacent side. This is the hypotenuse side. Now the ratios of these sides are represented as sine, cosine and tan. Say for example, if I were to take sine theta is nothing but opposite side divided by hypotenuse. Right? So cos theta is going to be adjacent side divided by hypotenuse. And tan theta is going to be opposite side divided by adjacent side. So this is the ratios, or I should say these are the trigonometric ratios by which the right triangle is represented. Now foremost, let us talk about f of x is equal to, say, sin x. Now the graph of sin x is actually in this fashion. So it starts from 0 and it hits 2 pi over here. Right, so at pi the graph will hit 0, and at pi over 2 the graph will hit positive 1. Right, and at 2 pi the graph hits 0 again. Now between pi and 2 pi you have a value called as 3 pi over 2. At 3 pi over 2 the graph will hit negative 1. So if you were to extend this sin x graph, sin x will not go beyond negative 1 on the negative side of the axis, and it will not go beyond positive 1 on the positive side of the axis. And this curve will be repeating up until infinity, both on the left side and the right side. So if you were to talk about the domain means the values that x can take. X can take all values that are contained in the real number, but the function can only take values between negative 1 and positive 1. So the range is between negative 1 and positive 1. This is a very important concept that you will have to understand. Right? So the next point is periodicity. The period is the graph will repeat itself at every 2 pi intervals. So 0 to 2 pi, this will be the loop. Again another 2 pi, the same loop will be repeating. So the graph will be moving up like that. So the period is 2 pi. Is the function even or odd? The function is an odd function. Now what exactly does it mean when I say the function is odd? F of negative x is equal to negative f of x. This is the meaning of it. So if I were to take x is equal to negative x into this function, it will produce me negative f of x. So sin x is an odd function. Now is sin x a bijective function? Is it bijective? Bijective means is it one-to-one onto, or in other words, is it injective or surjective? No, sin x is not a bijective function. So when I say bijective, it should be one-to-one, but it isn't. Say for example, if I were to take a point, say 1 over 2, and if I were to draw the line, it fails the horizontal line test. So that means over here the curve, as I mentioned to you, would be repeating itself like this, right? And then it will be going up again. So according to the horizontal line test, the intersection of the line and the curve should occur at only one point. But in case of this particular point 1 over 2, the number of intersection that is taking place is infinite. So the function is not bijective. Of course, it is just an additional information that I wish to provide you here. So having given you this, let us move on. So the next function we would like to discuss would be the cos x function. So if you were to draw the graph at the 0, cos x will hit 1 and it will go down and it will come up like this, and then it would move up like this and the wave would be produced. So this is x, right? So this is the approximate graph for cos x. Now at exactly pi over 2, cos x will hit 0, right? That is important. And at pi, cos x will hit negative 1. And at 0, cos x will hit positive 1. And this order would be repeating itself. Now if you were to take 2 pi, cos 2 pi is positive 1, so it hits positive 1 here. So that is the graph. And if you were to write the domain is all x element of real number. So it can take any value on the x-axis. But the range will be only from negative 1 to positive 1. That is the range of cos x. And the next important point you will have to know is it is periodic. And the period is 2 pi. Alright? Because it starts here and it ends here. So you will have to make that observation. Sin x is also periodic. But the only point that is splitting cos x and sin x is the point 0. When x is equal to 0, sin x is 0, but cos x hits 1. So at 2 pi, it hits 1 again. So that is a full form, or I should say a loop, one complete wave that has been created by the cosine graph. So its period is 2 pi, and the next important point you will have to know is it is an even function. Okay, it's an even function. So meaning f of negative x will give me f of x. That's the idea here. So if you were to substitute x is equal to negative x in cosine function, it will produce the function back again. And another important point you will have to know, if f of x is equal to cos x, it is not bijective, as I mentioned to you. Now why am I so much concerned about bijective? It means, does this function have an inverse? No. Cos x does not have an inverse. To have an inverse, the function should be bijective. So cos x is not bijective. Clearly, if you can apply the horizontal line test, you can see that the intersection is at multiple points. So the test for bijection will fail in the case of cos x. So have that in mind. Cos x does not have an inverse. So that's a critical point of observation. So having got this, let us move on to the next trigonometry function. And before I could go, cos x trigonometric ratio is adjacent side divided by hypotenuse side. Right, so this is the formula that we will be using. Now the next important function that we would like to study is the tan x function. Now tan x, you'll have to know when x is equal to 90, tan 90 will hit infinity. That is a very important point that you will have to take into account. In other words, for 2n positive 1 times pi over 2, tan of this value will be hitting infinity. for n taking values from 0, 1, 2 up until infinity, whatever be the case. So in this case, n is element of integers. So if we were to draw the graph, so this is 0, this is pi over 2, this is n is equal to 1, that would give me 3 pi over 2, n is equal to 2, it's going to be 5 pi over 2, n is equal to 3, 7 pi over 2. So the graph will be hitting infinity at all these points. So on the other end, this is negative pi over 2. This is going to be negative 3 pi over 2 and negative 5 pi over 2, negative 7 pi over 2. So the graph starts from 0, right? It is moving up, but exactly when it comes to pi over 2, it wouldn't, in fact it would just keep on moving. So this is the way the graph would move. And on the other hand, it will move up, down like this. So at x is equal to pi over 2, there is actually an asymptote here. So asymptote has to be drawn. So this is the way we draw the asymptotes. So there is no line of contact, or I should say there is no point of contact, right? So the line falls at negative pi over 2 and it rises at positive pi over 2. Now between pi over 2 and 3 pi over 2, you got a value pi, right? Now if you were to calculate the value pi, tan pi is nothing but sin pi divided by cos pi. Sin pi is 0, cos pi is negative 1. So at pi, the hit is at 0. So if I were to draw the graph hits this point like this and it moves up like that and it flows down. So there is an asymptote. So we need to draw that asymptote. And so similarly, it hits this point. There is a pi there, negative pi. So there is a hit and the graph moves up and it flows down. And we have to draw the asymptote. Okay. So that's an approximate graph. So I hope you are able to catch the gist of it. So similarly at 2 pi there will be a hit on the axis, on the x-axis, because that's going to give us 0, right? So having got that, let us write down the domain. Clearly I have mentioned to you, the domain would be all x element of R such that I need to get this point out. So it should not have 2n positive 1 times pi over 2. So this point should not be included such that n is element of z. So this point will be removed from the domain, because at that particular point the function is actually becomes out of bound, or the function vanishes actually, because of the fact that tan 90 hits infinity. In fact, it's the better way is to represent is it approaches infinity, because it can't hit infinity, it can only approach. Okay, approaches infinity. So that has to be removed from R. Now the range is, from the graph itself we can see that it's going to be R, right? Because you can clearly see it has the ability to go all the way down, it has the ability to go all the way up. So the best way to represent the range is the set R. And period, in this case, if you were to observe, at every pi the graph will repeat itself. So the periodicity for tan x graph is pi. Now since tan x has got sin x, the function is an odd function. So these are some of the important characteristics of the tan x graph, which is important to perform questions that are dealing with the function as such. Now we will start off with trigonometric formulas and identities that are required. So when I say trigonometric formula, it means it comprises of trigonometric table, the periodicities, and the reciprocal identities, the complete list. So that's exactly what I'm going to give you here. So foremost, let's start with something basic, identities. So the first and foremost one which we all are supposed to know is sine squared theta. I'm using theta, you can use theta, alpha, beta, or phi or x, because this just mentions an angle. Since it is conventionally used, I'm using theta there. So the first one is sine squared theta positive cos squared theta is equal to 1. The next one is sine squared theta is equal to 1 minus cos squared theta. The third one is cos squared theta is equal to 1 minus sine squared theta. And then 4, you got secant squared theta negative tan squared theta is equal to 1. And the fifth one is cosecant squared theta negative cot squared theta is equal to 1. So this comprises of basic identities. Now there is something called reciprocal identities which we will have to know. Reciprocal identities. So though they are all such presented in this following fashion. 1 over, in fact let me write it like this, 1 over sine theta is equal to cosecant theta. Number 2, 1 over cos theta is equal to secant theta. Number 3, 1 over tan theta is equal to cot theta. Right? So that's a very important formula that you will have to know. 1 over tan theta is equal to cot theta. Now these formulas can also be interchanged. Say for example, you can likewise write sine theta is equal to 1 over cosecant theta. You can just flip them, right? And cos theta is 1 over secant theta. So that is also possible, right? I have mentioned it for cosecant theta and secant theta, but we can also mention it in terms of sine theta. But usually they don't do it, but apparently it's always possible. So from here, in this case, formula number 6, I can write tan theta is equal to 1 over cot theta. So these can be used whenever there arises a demand, there arises a requirement. So we need to keep an open mind when it comes to problem solving. So it is imperative to mention here that all these are taken from right angled triangle. Right angled triangle. So you can use the word right angled triangle or right triangle. It doesn't matter because it has an angle 90 degrees. So let's move on. Now the next important information that we will have to have in our minds is what is called as the trigonometry table. Now you will have to apply some memorization techniques here, because that would come in handy, because we cannot be applying the formulae or resorting to the calculated every time we encounter an angle. So if you have it in your mind, stored in your mind, you can be efficient when it comes to solving questions against the race that time puts up. So let's start. So the first row will have angles in degrees, right? I'm giving it both angles in degrees, and the second row is going to have angles in radians. RAD stands for radians. So usually we start with 0 degree and then 30 degrees followed by 45 and then 60 and then 90, 180, 270 and then 360. That's it. So these are all standard angles which you have to know. So in terms of radians, 0 degrees is 0. This is going to be pi over 6. This is pi over 4. This is pi over 3. This is pi over 2. This is pi. This is 3 pi over 2 and this is 2 pi. Right? So now comes the famous sine. So when we are talking about sine, we are talking about sine 0. Right? So sine 0 is 0, sine 30 is 1 over 2, sine 45 is 1 over root 2, sine 60 is root 3 over 2, sine 90 is 1, sine 180 is 0, sine 270 is going to be negative 1, 3 pi over 2, and this one is going to be 0. So this is for sine. And then you got cos 0 is 1, cos 30 is root 3 over 2, cos 45 is 1 over root 2, cos 60 is 1 over 2, cos 90 is 0, cos 180 negative 1, cos 270 that's going to give me 0, cos 360 that's going to be 2 pi, that's going to be 1. So that's for cos. Now tan 0 is 0. Tan 30 is going to be 1 over root 3 because tan is sine over cos. So sine divided by cos, 1 over 2, root 3 over 2. So you flip it, you get 1 over root 3. And tan 45 is 1 and tan 60 is root 3. Tan 90 is infinity. Tan 180 is 0, right? And tan 270 is infinity again because of the involvement of pi over 2, and tan 360 is going to give me 0. So these are for the main trigonometric arteries, right? So now comes the reciprocal. So sine 1 over sine is cosecant, right? So what I can do now is I will start, instead of starting with cosecant, because cosecant and the sine are further away. So let me start something closer to tan. So that's going to be cotan. So cot. So cot 0 is actually, cot is 1 over tan, right? So 1 over 0 will be infinity. And this one is going to be root 3. This is going to be 1. This is going to be 1 over root 3. Tan 90 will give me 0 here, right? And tan 0 is going to be infinity. So this is 180 because tan 180 is 0. When it comes to cot, it's going to be infinity. And this is going to be 0 and this is going to be giving me infinity. So that's fine. That's a nice way to place the values. So now comes after cos, I should say after cot, you got cos. Cos is actually secant theta, right? So let me write that down so that we can go up further like that. So secant theta is nothing but 1 over cos, right? So secant 0 is 1. This is going to be 2 divided by root 3. I can write it like this. This is going to be root 2. This is going to be 2. This is going to be infinity, right? Because secant 90 is 0. So this is going to give me infinity. This is going to give me negative 1, this is infinity, and this is going to be 1. So that is for secant. So let me just draw the block. So now comes cosecant. Cosecant is actually 1 over sine, right? So 1 over 0, that's infinity. This is 2, this is root 2, this is 2 over root 3, this is 1, this is infinity, this is negative 1 and infinity. So this is what we have got for cosecant. So that's a nice way. So all that you need is 1, 2, 3, sine theta, cos theta and tan theta, and you will be able to complete this beautiful table. So we will move on, students. Now next comes what is known as sum and difference formula. So this is a very important concept you will have to know. The first one is sine of A positive B is equal to sine A cos B positive cos A sine B. Formula 1, formula 2. Sine of A minus B is equal to sine A cos B minus cos A sine B. Cos of A positive B is equal to cos A cos B minus sine A sine B. Cos of A negative B is equal to cos A cos B positive, and it is negative, it becomes positive, and this positive becomes negative. So it's going to be sine A sine B, right? Now we got a formula for tan. Tan of A positive B, this is very important, is equal to tan A plus tan B divided by 1 negative tan A tan B, and tan of A negative B, that's also critical, right? So that is going to be equal to tan A negative tan B divided by 1 positive tan A tan B. Now I can actually prove this, that tan of A positive B is equal to tan A positive tan B divided by 1 negative tan A tan B. So let me give you this proof. So I want to consider the right hand side, which is tan A plus tan B divided by 1 negative tan A tan B. So I know tan is sine A over cos A, and tan B is sine B over cos B divided by 1 negative sine A cos A sine B cos B. Now if you were to take the LCM, cos A cos B, this would give me sine A cos B plus sine B cos A divided by this, again I'm taking the LCM as cos A cos B, so that's going to be cos A cos B negative sine A sine B. So cos A cos B cos A cos B can be cancelled. Sine A cos B plus sine B cos A, what is that? That's nothing but sine of A plus B. So this is equal to sine of A plus B divided by cos A cos B negative sine A sine B. Cos A cos B negative sine A sine B. What is that? Cos of A plus B. So write that, cos of A plus B. Now what is sine over cos? Tan. What is the argument? A plus B. So which is equal to the left hand side. So this is just proof for you to understand. So having given that, let me move on to formula number 6. I have added this to 6. So in 6 we will have to look into double angle identities. So let me state the double angle identities. Now just some other information. Now I can similarly replace tan by cot. So let me just consider that. So tan is 1 over cot, right? So this is going to be 1 over cot of A positive B, which is equal to 1 over cot A plus 1 over cot B divided by 1 negative 1 over cot A times 1 over cot B. Now this is equal to, if I were to take the LCM as cot A, cot B, this is going to be cot B positive cot A divided by cot A, cot B negative 1 divided by cot A, cot B. Cot A, cot B, cot A, cot B can be cancelled. So you have 1 over cot of A positive B is equal to cot A plus cot B divided by cot A, cot B negative 1. So if I were to flip this, I move this and move this and I push that down. So I would get, therefore this would mean I got cot A, cot B negative 1 divided by cot A plus cot B. I've already moved this to the other end. So it's going to be cot of A positive B. So you got a beautiful formula here. So I can take this as 6. Cot of A positive B is this. Now simultaneously you can have cot of A minus B, right? It's all the same way. So we will stop with 6 and then we will move on to studying the formulae connecting double angle identities. The first and foremost formula that we will have to know is sine 2x is equal to 2 times sine x cos x. So this is of high importance. Okay, now from this there are other deductions that are possible. So let me just consider 2 times sine x cos x. Now what I wish to do is I would like to divide by 1 and then I would like to rewrite 2 times sine x cos x over 1 as sine squared x positive cos squared x. It's fair enough, right? Now I would like to take cos squared x out as a common factor and that would give me sine squared x over cos squared x positive 1. But sine x over cos x is equal to tan x and this would mean sine squared x over cos squared x is equal to tan squared x, right? So I can substitute that. So this is equal to 2 times sine x cos x divided by cos squared x of tan squared x positive 1. Now I would like to cancel a cos and a cos here, giving me 2 times sine x divided by cos x times, I'm going to write tan squared x positive 1 as 1 positive tan squared x. Right? Now let me divide the numerator and the denominator by cos x. So that would give me 2 over sine x divided by cos x divided by cos x divided by cos x times 1 positive tan squared x. Cos x gets cancelled, giving me 2 times sine x over cos x is tan x divided by 1 positive tan squared x. So I got a new formula. What is that? Sine 2x, which was written as 2 times sine x cos x, can also be written as 2 times tan x divided by 1 positive tan squared x. A very, very important formula that will come in handy in solving many questions. Now let's head on to cos. So formula 2. Now cos 2x is cos squared x negative sine squared x. So this is an important formula also. Now simultaneously we can have many representation for cos 2x. Since I've started with cos squared x negative sine squared x, I'm going to rewrite sine squared x as 1 minus cos squared x. So this is going to give me cos squared x negative negative positive cos squared x and a negative 1, which is going to be 2 times cos squared x negative 1. So this is another important formula. Now instead of replacing sine squared x with 1 negative cos squared x, what would be the situation if I were to replace cos squared x with 1 negative sine squared x? So that's going to be 1 negative sine squared x followed by a negative sine squared x, and this is going to give me 1 negative 2 times sine squared x. Another important deduction we have arrived at. So cos 2x can also be written as 2 times cos squared x negative 1, or 1 negative 2 times sine squared x, or cos squared x negative sine squared x. Now what we can further do is we can actually deduce cos squared x minus sine squared x again in a different fashion. So what I would do is I would like to write cos squared x negative sine squared x to be as cos squared x negative sine squared x divided by 1, now which is nothing but cos squared x negative sine squared x divided by 1 can be written as cos squared x positive sine squared x, right? Now let me take cos squared x out. So if I were to take cos squared x out, I would get 1 negative sine squared x divided by cos squared x for the numerator. In the denominator, again I wish to take cos squared x out. This is going to give me 1 positive sine squared x over cos squared x, right? Now cos squared x can be cancelled. Sine squared x over cos squared x is tan squared x. So I got 1 negative tan squared x divided by 1 positive tan squared x. You see that? This is also a very important deduction for cos 2x. To wrap up, let me give the equivalent for tan 2x. Now tan 2x is equal to 2 times tan x divided by 1 negative tan squared x. This is 3. And for secant 2x is equal to secant squared x divided by 2 negative secant squared x. And number 5, cosecant 2x. Let me write that down here. Cosecant 2x is equal to secant x cosecant x divided by 2. So these are all some of the double angle identities which would come in very much handy. So this is cosecant 2x, and secant 2x is secant squared x divided by 2 negative secant squared x. All of these things can be easily proved, and with that we will actually move on to other identities. Students, let us do the following questions to get a greater insight into trigonometry. So we are given this question: consider a square of side 4 centimeter and that a man runs at a distance of 1 centimeter from the sides of the square. Find the distance. They are asking us the total distance covered by the man. So we are given a square. So this is the square, and the sides of the square are given to be 4 centimeter, 4 centimeter, 4 centimeter, 4 centimeter. And a man is actually running, right? And the distance between the man and the square is 1 centimeter. So if the man is running along like this, this distance is 1 centimeter. So he runs like this. Naturally, he has to take a bend. Then he runs again. Over here, he has to take a bend. Then he runs again. Over here, he has to take a bend. Then he runs again. Over here, he takes a bend. So there are actually 4 bends. Now if you were to actually make an observation, you will find that there is a quadrant being made over here. There are 4 quadrants. So if there is a circle, if you were to divide the circle by 2 lines, you will see that 4 quadrants make up the circle. So actually what the man is doing, apart from covering the distance along the sides of the square, he is also covering one full circle. So the formula would be total distance covered by the runner, covered by the running man, is equal to the distance covered for the square, that's 4 into 4, plus the circle, that's going to be 2 pi r. So this is going to be 4 times 4, so let me just write that as 4 square, positive 2 times pi. My r over here is 1 centimeter, right? This is 1 centimeter, 1 centimeter and 1 centimeter. So r is equal to 1 centimeter. So that would mean I now have 16 positive 2 times pi. But if I were to take the value of pi as 3.14, then this would be 16 positive 8 to 6, and if I were to add 16 with 6, that would give me 6 added with 6 is 12, carry 1 to 22.28 cm. So this is the total distance covered by the runner. So that is the solution. Of course, this is a simple question, but it's always good to start with questions of meager sum difficulty and then gradually scale up. So we'll move on to the next. Formula 7. So I'm going to show you how exactly it is proved. So cosecant square theta negative cot square theta is equal to 1. So what I wish to do is I will say consider the left hand side. So what is on the left hand side? Cosecant square theta negative cot square theta. I'm going to replace cosecant square theta as 1 over sine square theta. Cot square theta is cos square theta over sine square theta. If I were to take LCM as sine square theta, I get 1 negative cos square theta. 1 negative cos square theta is sine square theta divided by sine square theta. They get cancelled, is equal to 1, which is equal to right hand side. So everything can be proved, and we will also be using cot theta to be as cos theta over sine theta and tan theta to be as sine theta over cos theta. So these are all some popular directions. So having given that, the next one that you will have to know is sine raised to the power of 4 theta positive cos raised to the power of 4 theta is equal to 1 negative 2 times sine square theta times cos square theta. This is a very popular identity which you will have to remember. Now how do I prove it? So let me just start out like this. Consider the left hand side, which is sine raised to the power of 4 theta positive cos raised to the power of 4 theta. I'm going to rewrite this as sine square theta positive cos square theta raised to the power of 2. If I expand this, I would get 2 times sine square theta cos square theta. So I can take that out. So this is going to be 2 times sine square theta cos square theta. But sine square theta added with cos square theta is 1. So this is going to be 1 negative 2 times sine square theta cos square theta. So this is a very important formula, and it is imperative that you take note of it. Now there is another important trigonometric identity which you will have to know, and that is sine raised to the power of 6 theta positive cos raised to the power of 6 theta is equal to 1 negative 3 times sine square theta cos square theta. Now I can give you the proof. So I'll start off like this. Consider the left hand side, which is sine raised to the power of 6 theta positive cos raised to the power of 6 theta. I'm going to rewrite this as sine squared theta raised to the power of 3 positive cos squared theta raised to the power of 3. Now there is a formula in algebra. We know that a cubed positive b cubed is a positive b times a squared negative ab positive b squared. So using this formula over here, this is nothing but a positive b. So sine square theta positive cos square theta times, and you have a squared. So a squared is going to be this raised to the power of 2. So that is going to be sine square theta. This is my a, right? But I have to raise it to the power of 2. So that would mean I got sine raised to the power of 4 theta negative ab. My a is sine square theta, my b is cos square theta. So this is going to be sine square theta cos square theta positive b squared. My b is cos square theta, squared is going to be cos raised to the power of 4 theta. So I can rewrite this. This is the formula. So I can rewrite this as sine square theta positive cos square theta is 1 times, I'm going to club these two together. This is going to be sine raised to the power of 4 theta positive cos raised to the power of 4 theta negative sine square theta cos square theta. But what is sine raised to the power of 4 theta positive cos raised to the power of 4 theta? This is the formula. You see that? Take this and substitute here. So this is going to be equal to 1 negative 2 times sine square theta cos square theta. Already there is sine square theta cos square theta. Sine square theta cos square theta can be added. So that would give me 1 negative 3 times sine square theta cos square theta. So this is a very important identity that you will have to remember. So what is the identity? The identity is sine raised to the power of 6 theta positive cos raised to the power of 6 theta is equal to 1 negative 3 times sine square theta cos square theta. Next we will have to know what is called as the cast rule. You can either call it as cast rule or the name that you would like to start with. You know, they will also mention it as ASTC rule, right? And then I will also explain to you the reduction formula. So it's a very important topic, and it's, I would say, it's the art of trigonometry. When I say art, I meant this art, right? The core concept in trigonometry. Now, if you were to take the quadrant, now we always refer trigonometry relativity with quadrant. Always we talk about the angles with reference to the fourth quadrant. So this is the first quadrant. So when I say quadrant, you spell it like this: Quadrant, the quadrant. So this is one quadrant. So this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Of course, the angles, the measure is from 0 to 180 degrees, and then it goes up to here 270 degree and ends here at 360 degrees. In the first quadrant, we say A. So that means all ratios are positive. All ratios are positive. So what does it mean all ratios are positive? It means sine is positive, cos is positive, and tan is positive, and the reciprocals. The reciprocal of sine is cosecant theta, it's positive. Reciprocal of cos theta is secant theta, it's positive. Reciprocal of tan theta, that is also positive in the first quadrant. Now in the second quadrant, only sine is positive. Only sine is positive, and its reciprocal. The reciprocal for sine is cosecant theta, right? And cosecant theta is positive. So
Only these two are positive in the second quadrant. In the third quadrant, tan is positive and it's reciprocal. That's hot. Only these two are positive. In the fourth quadrant, cos alone is positive and its reciprocal, which is secant theta, that is positive. So when we say exactly cast, so we talk about like the C-A-S-T. That's what we say. So have that in mind, and with some problems you will be able to gain a mastery on that. Now, having mentioned the cast rule, now let me mention the reduction formula. Now there are two important formulas which you will have to know, and they are very powerful. That is, if you were to be asked to find sine of some constant multiple of pi plus theta, the outcome will always be either plus or minus sine theta. There wouldn't be any change in this. The only thing that will change is the sign, either a plus or a minus, but sine will always be occurring with the angle. So this is one. The next formula is, if you were to be asked sine of some constant times pi over 2 positive theta, then the outcome would be plus or minus cos theta. So in this case, cos will be there no matter what, because of the fact that you got k times pi over 2. But the only change would be either a plus or a minus. So using this, we would be doing problems, and as I always mention, the best way to understand any concept is problem solving. So we will continue this lecture in the following class, students. Until then, have a nice night. Students, we would be finding now the value of the following. Now the first question is, what is the value of sine of pi negative theta? Now clearly in the formula I have given you, sine of k times pi positive theta would be equal to plus or minus sine theta, depending upon the quadrant that we have. So in this case, the problem is sine of pi negative theta. Now if we were to draw the quadrant, we know all ratios are possible. Sine alone is positive here, and tan is positive here, and cos is positive. So when I say cos is positive, it means cos and its reciprocals are positive. Sine and its reciprocals are positive. Tan and its reciprocals are positive. So this is going to be 0, this is 90, this is 180, this is 270, and this is 360 degrees. Now pi negative theta, now this is pi. Now whenever you have a negative sign, you are basically talking about a coordinate or a point between 180 and 90. So remember, always negative sign means you move up, positive sign you move down. So since it is in the second quadrant, sine is always positive here. So this is going to be, I know that it's going to be sine theta because of the formula I've given you, and the sine is going to be positive. So that is the solution for the first question. Now question number 2. Let us see what would be the situation if they have given us sine of pi over 2 negative theta. I've clearly given you the formula. Sine of k times pi over 2 positive theta is equal to plus or minus cos theta. So 90 degree is over here. I already told you, if it is negative, it will move in this direction. So that means we are looking at a quantity which is in the first quadrant. First quadrant means all ratios are positive, so the sign is going to be positive, but apparently we need to have a cos theta there because of the formula. So that is the solution for the second question. So let's go and do the third question. Third question wants us tan of pi positive theta. Now remember, the formula which I've given you for sine will also go for tan. Okay, so have that in mind. So in this case, we would be looking at, in this case we're getting sine here, so we would be getting tan here, tan theta. The main point is it a positive sign or a negative sign? Is it a plus or a minus? So as I mentioned to you, 180 is over here between the second quadrant and the third quadrant, and anything positive will be located over here. So this would mean tan is always positive in this case, so it's going to be plus or positive tan theta, depending upon what you would like to say, whether it's positive tan theta or plus tan theta. Now coming to the next question, question number 4. Let's see what happens to secant of 3 pi over 2 positive theta. Now what is secant theta? Now secant theta is nothing but 1 over cos theta. So it's a reciprocal of cos. Secant theta is a reciprocal of cos. Now we have secant of 3 pi over 2 positive theta. So the question is, what would be the output? Now when it is sine, please watch here, if it is sine k pi over 2 positive theta means we are getting cos. On the contrary, if it is cos, then we would get a sine. So in this case it is secant, so we would get a cosecant. Okay, so 3 pi over 2, 3 pi over 2 is nothing but 3 multiplied with 90, which is nothing but 270 degrees. So the position is over here, 270 degrees is over here. Positive sign, as I mentioned to you, positive means it will be located on this side. So over here cosine is actually a positive sign, positive ratio. Cosine along with this reciprocal, which is secant, will produce a positive ratio. So in this case we will have a positive sign. Okay, so moving on, let's do the next question. The next question is cot of 11 pi over 2 negative theta. Now what is this? Now as I mentioned to you, when we add tan, the outcome would be cot, but in this case we got cot because of the presence of pi over 2, so the outcome is going to be tan. Now the question is it a positive tan theta or a negative tan theta? That is the decision that we will have to take. So how do we take it? Now first foremost, let us find out what is 11 pi over 2. 11 pi over 2 is nothing but 990. Whenever an angle that we get is greater than 360 degrees, we have to keep subtracting 360 degrees from this angle until we get a value which is lesser than 360. So in this case you got 990. Let me subtract 360 degrees. So this is going to be 0, this is going to be 3, and from 9 I have to take away 3, I will get 6. So now I got 630 degrees. Again it's greater than 360 degrees. So subtract 360 degrees from this. So this is going to be 0. I borrow 1, 13. From 13 I take away 6, that will be 7. This is 5. From 5 I take away 3, it's going to be 2. So 270 degrees is less than 360 degrees. So we stop here. So where is 270 degree? It is between the third quadrant and the fourth quadrant. So this is the point that we are looking for. Now the question is, we have negative. So negative means we go towards the left. Okay, so this is the location that we are looking for. Now in this case tan is positive and its reciprocal is positive, that is cot is also positive, so we have a positive sign. Simple, isn't it? So finally let us talk about secant of 7 pi positive theta. Now what is this 7 pi? 7 pi is nothing but 7 times 180. What is that equal to? 0. 7 times 8, 7 8s are 56, 5, and 7 ones are 7, positive. We need to add 5, so we are getting 1260. So we have to subtract 360. So let's see what happens. So as I mentioned before, if an angle is greater than 360, you keep subtracting 360 from the outcome. So let me do that. 360, I'm subtracting, I get 0, 0. This is going to be 900. That's 9. So again it's greater than 360. I'm going to subtract 360 now. 0, 10 and 4. This is 8. I get 5. So 540. Again I subtract 360. So 0. This is going to be 8, 4, 180. So 180 degrees. So 180 degree actually lies between the quadrant 2 and quadrant 3. So this is the point that we're looking for. Now positive sign means it will go down. In this case only tan and its reciprocal cot is positive. So we will have a negative sign there, right? And since we are talking actually about secant is nothing but the reciprocal of cos. So directly this would also be cos. In this case, instead of we need to place a reciprocal for cos, right? So we will place here negative secant theta. Students, let's do this question. We are asked to find the value, and this is the expression that's been given. Tan pi over 11 positive tan 2 pi over 11 positive tan 4 pi over 11 positive tan 7 pi over 11 positive tan 9 pi over 11 positive tan 10 pi over 11. So this is the question that is being given to us. Now let me rewrite this as follows. This is, I'm not going to do anything to tan pi over 11, and I will also retain tan 2 pi over 11, and I will also retain tan 4 pi over 11. Now tan 7 pi over 11, I would like to write it as tan pi negative 4 pi over 11. 11 times pi gives me 11 pi, minus 4 pi divided by 11 would be 7 pi over 11. Positive, I want to write 9 pi over 11, tan 9 pi over 11 as tan pi negative 2 pi over 11. So this, if you were to simplify, this is going to be 11 pi minus 2 pi divided by 11. So that's going to be 9 pi over 11. So we would be getting this. So followed by positive tan pi negative, I would be having this as pi over 11, because 11 times pi gives me 11 pi minus pi, that's going to be 10 pi divided by 11. So this is what we would get. Now having obtained this, now we know that tan of pi negative theta, what is that? Tan of pi negative theta, this is going to give me tan theta, of course, that is there, but we need to decide on this sign, is it plus or minus. Now go to the quadrant. First quadrant, all ratios possible. Second quadrant, sine alone is possible. Third quadrant, tan is possible. I mean, when I say possible, it means positive, right? So that's exactly what I'm meaning. So all ratios are positive, sine alone is positive, tan alone is positive, cosine alone is positive with the fourth quadrant. Now, as I mentioned to you, when you talk about 180 is over here between the second and the third quadrant, and when you are required to subtract something, I told you, you should go above. So over here you go up, if it is positive you go down. So if you are here, you are expected to take a minus like this, you will have to go to the left, and positive sign will always lead you to the right. So I have already mentioned this. So in this case it's 180 negative. Over here negative means it lands up in the second quadrant, and only sign is positive here. So tan is not positive. So this would mean you would get a negative. We would be using this formula. So by this formula, what would happen? Let me rewrite that, the expression. So this expression would now be rewritten as, so let me have it like this, tan pi over 11 positive tan 2 pi over 11 positive tan 4 pi over 11. Now tan of pi negative 4 pi over 11. So this is going to be negative of the angle, right? So this is going to be negative tan this angle. That's going to be 4 pi over 11. So positive, this is tan of pi negative 2 pi over 11. So this is going to be negative, right? So it's going to be negative of tan 2 pi over 11. So it's already positive here. Positive times negative will become negative. So finally, tan of pi negative theta. So that's going to be negative tan theta. So this is going to be negative tan of pi over 11. So clearly positive pi over 11, negative pi over 11 can be cancelled. This is going to be negative tan 2 pi over 11 and positive tan 2 pi over 11. They can also be cancelled. This is tan 4 pi over 11 and followed by negative tan 4 pi over 11. So they can be cancelled. So giving me the output of 0. So that is the solution for this beautiful question. So we can move on to the next question. So next, students, we will have to deal with negative angles. What would be the situation when theta is negative? So when I talk about negative angles, we are talking about the trigonometric ratio of sine, cos and tan. So sine of a negative angle, that's negative theta, is going to be negative sine theta. A very important outcome. And cos of negative theta is equal to cos theta. And similarly, you got tan of negative theta is equal to negative tan theta. So the reciprocal of sine is cosecant. Similarly, cosecant of negative theta is equal to negative cosecant theta, and reciprocal of cos is secant. So secant of negative theta is equal to secant theta. Reciprocal of tan is cot. So cot of negative theta is equal to negative cot theta. This is called even function. And this along with this are called as odd function. Okay, so have that in mind, even function and odd function. Let's do this question, students. We are expected to find the value of sine for 20 degrees times cos 390 degrees positive cos 300 degrees times sine of negative 330 degrees. Now, since sine of negative theta is negative sine theta, I would be using that over here and rewriting this entire component as, this is sine 420, right? So this is going to be sine of 420 cos of 390 negative cos 300 times sine 330. This is what I've got. Now let me evaluate first sine 420. Now I would like to write sine 420 as sine of 450 negative 30. Now I've told you already, if you are given an angle which is greater than 360, this is clearly greater than 360, subtract 360 from this. So 450 negative 360 would give me 90 degrees. So that means we are looking at an angle which is actually between, or I would say it is in the between first and the second quadrant, right? So 90 degrees over here. So this is what we are looking at. Now I can actually rewrite this as sine of 5 times pi over 2, because this is going to give me 90. 90 times 5 is going to be 450 negative. This is actually, let me just take it as theta. So from the formula which we have studied earlier, this is going to be equal to cos, right? So this is cos theta. The only thing is that we are worried about the sign, whether it's positive sign or negative sign, because it's 90, so it's over here. So that means All ratios are positive. So it's going to be positive cos theta. So according to this, of course, we don't have to mention this. This is for your understanding. So what I'm going to do is I'm going to rewrite this as sine of 5 times pi over 2 negative 30 degrees, which is nothing but cos of 30 degrees, and the sign is actually a positive sign. Okay, because when we talk about the sign being negative, so it would be on the first quadrant over here. So that's why I'm just taking it as positive. In fact, it is positive. But what is cos 30? Cos 30 is going to be root of 3 divided by 2. This is the value for sine of 420. So we have got that value, and let me place it in a box. Now next comes cos of 390 degrees. Now what is cos of 390 degrees? I can write cos of 390 degree as cos of 360 degree positive 30 degrees, right? Now what is this? This is nothing but cos of 2 times pi. This is k times pi positive theta. Now this is going to be equal to cos theta. There wouldn't be any change in it, but the only thing is that is it plus or minus. Now 360 degrees is over here, right? So if I were to talk about a positive sign over here, if we are going to take a plus, it will land up in the first quadrant where all ratios are positive, right? So that would mean this is rewritten. Anyway, this is basically the formula which we have. So it's going to be positive here. So let me write the outcome here. So it's going to be cos of 2 times pi positive 30 degrees, which is going to be positive cos 30, which is going to be root of 3 over 2. So we have got the value for cos. So in fact this is actually cos of 390 degrees. So this is the value for cos 390. So having obtained cos 390, let us obtain what is cos 300 degrees. Now cos 300 degrees is nothing but, I can rewrite this as cos of 360 degree negative 60 degrees, right? Now this is nothing but cos of 2 times pi negative theta, right? So in fact it's I can just, let me just write the formula out. So this is going to be cos of theta, but we are not sure if it is going to be plus or minus. So let me check that out. So 360 degrees over here. So if it is minus, it is going to come down here where cosine is positive. So it's going to be positive sign there. So that would mean this is equal to cos of 2 times pi negative 60, which is equal to positive cos of 60, which is nothing but 1 over 2. So that is the value for cos 300 degrees. So now comes sine. We need to find sine 330 degrees. Now sine 330 degree is nothing but sine of 360 degrees negative 30 degree, which is nothing but sine of 2 times pi negative 30. Now of course we all know this is going to be sine 30, but the question is it positive or negative? So 360 is here. Now if I were to take a negative of this, okay, it is going to come down here. Only cosine is positive, so it's going to be negative sine 30, which is nothing but negative 1 over 2. So if I were to take the values and substitute, so therefore this would imply, let me write down the question, sine of 420 times cos of 390 negative cos 300 times sine 330 is equal to sine 420 is root 3 over 2 times sine cosine 390. Cosine 390 is root of 3 over 2 negative cos 300. Cos 300 is 1 over 2 times sine 330. Sine 330 is negative 1 over 2. So this is going to give me root 3 times root 3 gives me 3. 2 times 2 gives me 2 squared. 1 times 1 with a negative sign gives me positive. It's going to be 1. 2 times 2 is going to be 2 squared. I take the LCM as 4. This is going to be 3 positive 1, which is nothing but 4 divided by 4, which is equal to 1. So this is a beautiful question, and it requires some working. So I hope you enjoyed this question, students. We'll move on to the next one. Students, let's do this question. We are expected to evaluate the following expression, which is 3 times of sine raised to the power of 4 of 3 pi over 2 negative alpha positive sine raised to the power of 4 of 3 pi positive alpha negative 2 times of sine raised to the power of 6 of pi over 2 positive alpha positive sine raised to the power of 6 of 5 pi negative alpha. Right, now this is going to be cos, and because of even power, plus or minus, it's not going to matter. So this is going to be cos raised to the power of 4 alpha. Positive, this is going to be sine. As I mentioned to you, the degree is 4. So this would produce as sine raised to the power of 4 times alpha. Negative 2 times, this would produce as cos raised to the power of 6 times alpha. This would produce as positive sine raised to the power of 6 times alpha. So this is what we've got. Now I will be using the identity. What is identity? We know that since we know that sine raised to the power of 4 alpha positive cos raised to the power of 4 alpha is equal to 1 negative 2 times sine squared alpha times cos squared alpha. Also we know that sine raised to the power of 6 alpha positive cos raised to the power of 6 alpha is equal to 1 negative 3 times sine squared alpha times cos squared alpha. These two identities we proved. So with the help of the identity, I am going to rewrite this as 3 times of 1 negative 2 times sine squared alpha times cos squared alpha negative 2 times 1 negative 3 times sine squared alpha times cos squared alpha. Now this implies you now have 3 negative, 3 times 2 is 6. So let me write that 6 sine squared alpha cos squared alpha negative 2 times negative negative positive 6 times sine squared alpha times cos squared alpha. Positive 6 times sine squared alpha times cos squared alpha can be cancelled with 6 times sine squared alpha cos squared alpha with a negative sign. 3 added with negative 2 would give me 1. So this is the solution for this beautiful question. And these are some of the important identities you will have to know. So to start with, sine of A positive B is equal to sine A cos B positive cos A sine B. Identity 2, sine of A negative B is equal to sine A cos B negative cos A sine B. Identity 3, cos of A positive B is equal to cos A cos B negative sine A sine B. And finally cos of A negative B is equal to cos A cos B positive sine A sine B. So when we talk about compound angles, these are the compound angle formula connected with sine and cosine. So having mentioned this, let's move on, students. Now having given you the compound angle formula for sine and cosine, now let me give you the compound angle formula involving tan and cot. So let me write down compound angle identities, in fact. I call them as identities involving tan and cotan. So the first and foremost important one is tan of A positive B is equal to tan A positive tan B over 1 negative tan A tan B. Formula number 2, tan of A negative B is equal to tan A negative tan B divided by 1 positive tan A tan B. So this is for tan. Now let me write the equivalent for cotan, that's cot. So cot of A positive B is equal to cot A cot B negative 1 divided by cot A positive cot B, and cot of A negative B is equal to cot A cot B positive 1 divided by cot. In this case it would have to have a reversal here. So this is A minus B, so we won't have it as cot A negative cot B, we'll have it as cot B negative cot A. So that is how it would be obtained as. Now we can verify all of this, right? It's possible to verify each and every formula, and that wouldn't be a difficult task. So having given this compound angle formula, I would suggest that you practice them thoroughly so that it becomes second nature for you. Now let me just show you the proof of one of these formulae. So I would like to show you how exactly cot of A negative B is equal to cot A cot B positive 1 divided by cot B negative cot A. Now all I wish to do is I would like to consider the right hand side. So what do we have in the right hand side? We got cot A cot B positive 1 divided by cot B negative cot A. Now I can rewrite cot A as cos A over sin A times cot B as cos B over sin B positive 1 divided by cot B as cos B divided by sin B negative cot A as cos A divided by sin A. Now if I were to take the LCM for the numerator, this is going to be sin A sin B, and I would have cos A cos B positive sin A sin B, right? This entire thing is divided by, if I were to take the LCM as sin A sin B, I would get cos B sin A negative cos A sin B. Now this has to be divided by sin B sin A. Clearly you can see sin A sin B sin B sin A, they can be cancelled, giving us cos A cos B positive sin A sin B divided by, I can write this as, okay, let me write it as cos B sin A negative cos A sin B. So this is what I've got. Now cos A cos B, and I've got sin A sin B. So this is going to be cos of A minus B divided by, now I got sin A cos B negative sin B cos A. So what is this? This is nothing but sin of A minus B, right? But what is cos over sin? Cos over sin is nothing but cot. And what do we have? we got a minus b. And what is that? That is nothing but equal to the left hand side. You see that? So hence proved. So that's the end of solution. So having given you all this, there is one more important formula you will have to know. So this is 1, 2, 3 and 4. There is a fifth one which is very important, and that is tan of pi over 4 plus or minus a, which is equal to 1 plus or minus tan a divided by 1 minus or plus tan a. Now this result can be easily proved from tan of a plus b formula, right? So I can just show you this. So if we were to ask tan of pi over 4 positive a, we can just use tan of a plus b, which is nothing but tan a plus tan b divided by 1 negative tan a tan b, which is in this case is going to be tan pi over 4 plus tan a divided by 1 negative tan pi over 4 times tan a. Tan pi over 4 is 1 positive tan a divided by 1 negative tan pi over 4 is 1 times tan a. So have that in mind. This is 1 plus tan a divided by 1 minus tan a. So this is what we have got for tan pi over 4 positive a. So this is the result. So the result can also be obtained for tan pi over 4 negative a. So the sign will get reverted. So having given you all this formula, we can move on to do application oriented questions. So when I mean application oriented question, I mean how exactly or where exactly we apply these compound angle identities. Students, we are going to see further important identities which would come in very much handy. The first one is sine of a positive b times sine of a negative b is equal to sine squared a negative sine squared b. This is a very important identity. The question is, how are we going to get it proved? So let me just start off like this. Consider the left hand side, which is sine of a positive b times sine of a negative b. We know the formula for sine of a positive b or a plus b, which is sine a cos b positive cos a sine b. This has to be multiplied with sine of a minus b, which is nothing but sine a cos b negative cos a sine b, right? So this is a plus b times a minus b, which is nothing but a squared minus b squared. So this is rewritten as sine squared a times cos squared b negative cos squared a times sine squared b. I would like to rewrite cos squared b as 1 negative sine squared b, and similarly I would like to rewrite cos squared a as 1 negative sine squared a. I would like to distribute the quantity, so that would give me sine squared a negative sine squared a times sine squared b negative sine squared b negative negative positive. This is sine squared a times sine squared b. Negative sine squared a times sine squared b would be cancelled with positive sine squared a sine squared b, thereby giving me sine squared a negative sine squared b, which is equal to right hand side, hence the result. Right, so this is a very important identity that we would be using in future. So having obtained this proof, we will move on, students. So similarly, there are two more identities which are important, and that would be involving cos of A positive B multiplied with cos of A negative B, which is equal to cos squared A negative sine squared B is the second one, and there is the third one, which is nothing but tan of A positive B positive C, which is equal to tan A positive tan B positive tan C negative tan A tan B tan C divided by 1 negative tan A tan B negative tan B tan C negative tan C tan A. Right? Now next comes what we call as the transformation formulae. So we looked into the product when sine of A positive B is multiplied with sine of A negative B. Now it is addition, right? Summation. So the first one is going to be sine of A positive B positive sine of A negative B is equal to 2 times sine A cos B, followed by sine of A positive B negative sine of A negative B is equal to 2 times cos A sine B. So have that in mind. So in this case it's cos A sine B. And formula 3, cos of A positive B positive cos of A negative B is equal to 2 times cos A cos B. And formula 4, cos of A negative B followed by a negative sign cos of A positive B is equal to 2 times sine A sine B. Now having given you all this, if I were to take A positive B to be equal to C and A negative B to be equal to D, if I were to add them, this is going to be 2A is equal to C positive D. Therefore A is C positive D divided by 2. Now if I were to take the value of A and substitute it over here, then I can suitably extract the value for B, which would be C negative D divided by 2, right? Because instead of adding here, if you were to get rid of A, let me show you that also. So I get A positive B is equal to C. In this case A negative B is equal to D. I can subtract and get rid of A. So this is going to be negative, this is going to be positive, this is going to be negative. So A gets cancelled, giving me 2 times B is equal to C negative D. Therefore B is equal to C negative D divided by 2. So this is the value for B, right? So if I were to substitute them in formula 1, what would happen? So therefore I can rewrite 1 to be as sine of A positive B. In place of A positive B is going to be sine C positive A negative B, which is going to be sine D is equal to 2 times, in place of A it's going to be C positive D divided by 2 sine of C positive D divided by 2 times cos of C negative D divided by 2. So this is a important formula Now I can just change everything. So formula 2, let me just write that down. Formula 2 can now be rewritten as sine of A plus B, which is nothing but sine C negative sine D is equal to 2 times cos of A, which is C positive D divided by 2, times sine of B, which is C negative D divided by 2. And formula number 3 is going to be cos A positive B, which is cos C positive cos of A negative B, which is D, is equal to 2 times cos of A C positive D divided by 2 times cos B, which is C negative D divided by 2. And formula number 4 is also rewritten as cos of A negative B, which is cos D negative cos A positive B C cos C is equal to 2 times of sine of A, which is C positive D divided by 2, times sine of B, which is C negative D divided by 2. Very important formulae. Okay, so you will have to practice them. So practice makes perfect. Students, let's do this beautiful question by applying the formula which we just studied. So the question is given as follows: let alpha comma beta be such that alpha negative beta lies between pi and 3 pi. Now if sine alpha positive sine beta is equal to negative 21 over 65 and cos alpha plus cos beta is equal to negative 27 over 65, then we are expected to find the value of cos of alpha negative beta divided by 2. Now this is the question. Now let me start the solution in this fashion. Given, what is given? Sine alpha plus sine beta is equal to negative 21 over 65. Now there is a formula which connects sine alpha positive sine beta. What is the formula? Sine C positive sine D is equal to 2 times sine of C positive D divided by 2 times cos of C negative D divided by 2. So this is nothing but 2 times sine of alpha positive beta divided by 2 times cos of alpha negative beta divided by 2, right? So this is equal to negative 21 divided by 65. So that's what we have got. Now also what we have got also given is cos alpha plus cos beta is equal to negative 27 divided by 65. So there is also a formula which connects cos alpha added with cos beta. What is that? That's cos C positive cos D. Now that is nothing but 2 times cos of C positive D divided by 2 times cos of C negative D divided by 2. So we get cos and a cos, but in this case we get sine and a cos. So this is going to be 2 times cos of alpha positive beta divided by 2. I'm just applying the formula. Positive cos of alpha negative beta divided by 2 is equal to negative 27 divided by 65. Now I'm going to divide one by the other. Okay, so this is going to be equal to 2 and 2 can be cancelled. cos alpha negative beta divided by 2, cos alpha negative beta divided by 2 can be cancelled. So this is going to give me sine of alpha positive beta divided by 2 divided by cos of alpha positive beta divided by 2 is equal to negative 21 over 65. I flip it, I get 65 over negative 27. They become positive. 65 gets cancelled. This is 21 over 27. Now 3 divides here 7 times, 3 divides here 9 times. So this is 7 over 9. I can rewrite this as tan alpha positive beta divided by 2 is equal to 7 over 9. Now let me go and draw the right triangle. Now this is theta, opposite side by adjacent side, hypotenuse side. Now the angle given is alpha positive beta divided by 2, and opposite side is 7, adjacent side is 9, and this hypotenuse side is going to be 9 squared positive 7 squared. So what is that? 9 squared is 81, 7 squared is 49. So what do we get? 81 added with 49, 9 added with 1, 10, carry 1. This is 12 and 13, 130. So that's going to be, this is going to be root of 130, right? Now this is for sine, so therefore, this is for tan, right? The values that we have just applied is for tan. From here we extract the value for sine. Therefore sine of alpha positive beta divided by 2 is going to be opposite side divided by hypotenuse side. What is opposite side? 7. Hypotenuse side is root of 130. This is for sine of alpha positive beta divided by 2. But we are expected to find the value for cos of alpha negative beta divided by 2. How am I going to get that? By using this equation, right? So if I were to name this as 2, therefore using 2 we get, what do we get? First write that down. 2 times sine of alpha positive beta divided by 2 times cos of alpha negative beta divided by 2 is equal to negative 21 divided by 65. This is going to be 2 times sine of alpha positive beta divided by 2 is 7 divided by root of 130. We need cos of alpha negative beta divided by 2, which is equal to negative 21 divided by 65. Now I have to use this part of the page, right? So if we were to flip it, or I should say cross multiplying, is going to be negative 21 over 65 times root of 130 divided by 2 times 7, right? Now what happens here? If I were to, 7 divides here 3 times, right? And is there anything else I can handle with? I cannot handle anything else much more. So that's the last thing I can handle. So this is simplified, and we can just reduce that. So I can use this side. So this is going to be equal to, let me write that down, negative 3 times root of 130 divided by 2 times 65. So that's going to be 130, right? So this is 130. And I can further rewrite this as 3 times root of 130 divided by, this is going to be root of 130 times root of 130. I can cancel one of this, giving me negative 3 times root of 130, right? So this is the value for cos of alpha negative beta divided by 2. So this is the solution. Of course we need to do some, some simplification is required, but it's still okay. So we have achieved the solution. And that's the important part of this particular question. Let's do this question, students. We are expected to find the value of sine 15 degrees. So how are we going to do this? Now, I would rewrite sine 15 degrees to be as sine of 45 degrees negative 30 degrees, right? Then I would apply sine of a negative b formula. Now what is sine of a negative b formula? We know that sine of a negative b is sine a cos b negative cos a sine b. So by this formula, this is going to be sine 45 cos 30 negative cos 45 sine 30. Now we know that sine 45 is 1 over root 2 and cos 30 is root 3 over 2. Cos 45 is 1 over root 2. Sine 30 is 1 over 2. So this is going to be root of 3 over 2 times root 2 negative 1 over 2 times root 2. If I were to take the LCM as 2 times root 2, I would get root 3 negative 1. I wish to multiply the numerator by root 2 and divide by root 2. This would give me root of 3 times root 2 would give me root 6 negative root of 2 divided by 2 times root 2 times root 2, that's going to be 2 times 2, which is rewritten as root of 6 negative root of 2 divided by 4. So this is the value for sine 15 degrees. Now there is an interesting observation that we can make here. Now sine 15 degrees can be rewritten as sine of 90 minus 75 degrees. But what is this 90 degrees, which is nothing but sine pi over 2 minus 75. This comes back to our popular formula which we started off in the beginning of this particular lecture, and this is going to give me cos, and in place of theta I've got 75. Now this is actually 90 minus theta, so 90 is over here between the first and the second quadrant, and minus, in this case all ratios are positive, so that's going to be plus here. So in other words, our sine 15 is also cos 75 degrees, so have that in mind. Now what if they ask us to find sine 75 degrees? Now this can be rewritten as sine of 45 degrees positive 30 degrees. By using the formula sine of a positive b, we get sine 45 times cos 30 positive cos 45 times sine 30. Sine 45 is 1 over root 2, cos 30 is root 3 over 2, cos 45 is 1 over root 2, sine 30 is 1 over 2. So if I were to take the LCM as 2 times root 2, this would give me root of 3 positive 1. I wish to multiply the numerator by root 2 and divide the quantity by root 2. So this is going to give me root of 6 positive root of 2 divided by 4. And what is this? This is nothing but sine 75 degrees. Students, I wish to give you further identities which are very important, which would come in very much in handy to solve questions. That would be sine A times sine of 60 negative A multiplied with sine of 60 positive A is equal to 1 over 4 times sine 3A. So this is one identity. The second one is for cos. Cos A times cos of 60 negative A times cos of 60 positive A is equal to 1 over 4 times cos 3A. Now if we were to divide 1 by 2, then we would get the third one, and that is going to be sin A over cos A. That's nothing but tan A. Similarly, sin 60 negative A divided by cos 60 negative A, that's going to be tan of 60 negative A. Sin 60 positive A divided by cos 60 positive A, that's going to be tan of 60 positive A. 1 over 4 will be cancelled with 1 over 4, giving me tan 3A. So that's a very good identity we have got, students. Now you might be wondering, how is it we are going to achieve a proof for this? Now let me just give you that. Foremost, let me state the identity. This is what we have been given. Sine A times, now I would like to write this as sine of 60 positive A times sine of 60 negative A. Fair enough, it's not going to make any change at all, which is equal to 1 over 4 times sine 3A. We are expected to prove this. So what I would like to do is, I would like to start off by stating, consider the left hand side. What is that? Sine A times sine of 60 positive A times sine of 60 negative A. Right? Now we know a very important result. What is that? Sine of A positive B multiplied with sine of A negative B is equal to sine squared A negative sine squared B. We just saw this result. So this would mean I can now rewrite sine A times sine of 60 positive A times sine of 60 negative A to be as sine A stays as it is, parenthesis, this is going to be sine squared of 60 negative sine squared A. Now what is sine 60? Sine 60 is root 3 over 2, right? So sine squared 60 is going to be root 3 over 2 squared, which is nothing but 3 over 4. So I would substitute that. This is equal to sine A divided by 3 over 4 negative sine squared A. If I were to take the LCM as 4, this is going to be 4 times sine squared A divided by 4, which I can rewrite it as 3 times sine A negative 4 times sine A times sine squared A. That's going to be sine cubed A divided by 4. I can take 4 out and rewrite this as 3 times sine A negative 4 times sine cubed A, which is equal to 1 over 4 times sine 3A, which is equal to the right hand side, hence the result, right? It's a beautiful result. So students, we will continue our study in the next lecture.